Hello everybody, welcome to this CP311 Internet Programming and Applications 2 lecture series. So this is the first lecture of this lecture series. So the credit for preparation of these slides goes to Mr. Sifal, who is a lecturer at the University of Dodoma. So without further ado, let's start with this. So Major will be doing the theory part through this lecture series. The practical part will be in another series, okay? So first of all, today I'll be doing XML. So XML literally stands for Extensible Markup Language. I'm sure you've heard of XML, somewhere maybe you've heard of it. So it's actually a markup language, and this is what it stands for, the Extensible Markup Language. So it was developed from the Standard Generalized Markup Language, the SGML, okay? So why was XML designed? So XML literally was designed to transport and store data. Okay, so XML really does not do anything. Okay, so it just transports and stores data. Okay, so understanding why XML, what XML does, will help you know when or when not to use it. Okay. So XML is a meta language, which is simply which simply means the language used to define other languages. So you can use XML to define a language like WML, for example. And WML stands for Wireless Markup Language. It's probably is a markup language that's used to design websites in mobile phones. So the WML, the wireless markup language, so that's what it does. So there are very many markup languages, including HTML, HTML, so many. So really, there are very many. So what you just need to know is um, basically what to use. And XML is highly recommended, it's highly popular, and largely supported. Okay, so the deficiencies of HTML and SGML that XML covers is that there's lacks syntactical rules and many complex features that are rarely used. So XML can be written by hand or it can be generated by computer. Both are possible, and either approaches are used. So it's useful for data exchange. So like I said, it's used for transporting and storing data. So it majorly deals with data. So XML documents are processed by parsers, and the parser is the program that analyzes syntax and structure of a given file. So it's parser. Okay, so they're processed by parsers. Okay, so XML tags are not predefined. It's different from HTML, or you can have the header tags, the H1 tag, H2, they're already predefined for you to use. In XML, it's quite different. If you've done XML, if you've done HTML, you'll be quite surprised when you start writing XML. It's actually you define your own tags and they work perfectly without any problems. Okay, so it's designed to be self-descriptive. So like you define the data structure of whatever data that you want to transport or store. So XML is the W3C recommendation since 1998. Okay, so it's actually recommended to, it's actually a very highly recommended markup language. Okay, so it does not replace HTML. Okay, so it just does storing and um, transportation of data, but it's nowhere near replacement for HTML. So what can we do with the XML? So we can define data structures and we can define them to our likeness. So we can define them to fit what we want these data structures to be like, because it doesn't have predefined tags, we define our own tags. Okay, so these structures are platform independent. Okay, um, because it's just data. Okay, it means software and hardware can really easily interact with XML. So process XML defined data automatically. Uh, so with XML, each data can be processed automatically, and you can define your own tags. So you're not like constrained into using predefined tags, because XML does not have predefined tags. So what can you not do with XML? So these are places where you don't want to use XML because it cannot work in those scenarios. So define how your data is shown. So you really can't try to define the outlook of your data, like how your data will be displayed, okay? Because this is not what XML does. So to show your data, you need other techniques. You need maybe to use HTML to show how your data, to describe your data to the user. By description, I mean like how is it arranged, how is it displayed to the user. That is not something that XML does. It just brings the data, the way you define it, the way it is displayed to the user depends on you can use HTML, for example, to process XML data and show it, let's say, in tabular form, in like a pie chart. You can use so like that. So it doesn't define how the data is shown. It just stores data, transports data, and like that. So XML and HTML are different indeed. So XML and HTML are designed with different goals. They can interact, but they have far-fetched goals. So XML is designed to transport and store data with focus on what the data is. So XML majorly focuses only on data, mainly on data. But HTML is designed to display data, and this is something that everyone who's done a bit of programming with HTML knows. Okay, so HTML majorly focuses on on how the data looks. Okay, so HTML is the markup language used to define the layout of any kind of information. Okay, so the layout, the general appearance, the lookout, that's what HTML does. XML is a meta markup language. Like I said, it is a meta language, is a language that's used to define other languages. Okay, so XML does not have predefined tags, whereas HTML tags are predefined. So you can see them in the documentation to HTML. All tags are predefined. You want to display a table, you have to use the table tags. You want to have a header, uh, the footer, the predefined tags for all those tasks. In XML, all opening tags must have a matching closing tag. So you open a tag, it's not predefined like name tag, have to have a corresponding closing name tag. Okay, and this is something that's not a request for HTML, because you have some tags like the input tag, for example, in HTML does not have a closing tag. So okay, so why do we need XML? Simple, it's just one answer. For data, everything has to do with data, majorly data exchange. So XML is majorly for data exchange. So it makes possible to define data in a clear way, because you don't have constraints. You can define your own tags. So it gives you much more room to define your data in the clearest way possible. So both the sending and the receiving party will use XML to understand the data that's being sent. Okay, this makes sense, because you want to have something that can you have to have a way to understand the sent and the received data. And by using XML, everybody knows that the same interpretation of data is used for replacement of So by using the XML, everybody knows that the semi-interpretation of the data is used, which is a replacement for electronic data exchange that has been used for several years to exchange data between businesses. So XML is doing it well. So EDI is expensive, okay? So it uses dedicated communication infrastructure and something that long run you don't want to have such means of exchanging data in a business. So with XML things are much more easy, and the definition used are far from flexible. Okay, so XML is a very good and perfect replacement for the electronic data interchange. So it uses internet for the data exchange, and it's very flexible. So the internet, everybody has the internet. So just having the internet, which everybody does these days, so it makes XML very much cost effective, literally free. Okay, so why do we need XML? So more reasons to why you need to use XML. Okay, the advantages that it provides. So XML makes communication easy. So it's a great tool for transactions between businesses. Like I say, they used to have um, electronic data exchange. They used to have electronic data interchange, EDI, which required specific communication infrastructures. But XML just requires the internet. So it's actually a very effective way for data transaction between businesses. So you can define other languages with XML. It's a meta markup language, so you can define other languages. So a good example is wireless markup language, like I said in the first slide. The language used in WAP communication. So it's majorly used in mobile app, in mobile phones. Okay, so WML is majorly XML dialect. So with XML, WML was made, derived from. Okay, so rules for writing XML documents. Despite not having predefined tags, despite it being freely and flexible, it still has rules that you have to observe if your XML document is to work as planned. So a well-formed XML document has correct XML syntax. So it does have syntax. Okay, it has the syntax rules that you have to obey. So it conforms to the general rules of the XML syntax. So XML documents must have a root element. Okay, so we'll see what this root element is, but it has to have a root element. The XML elements must have a matching closing tag. Okay, so you define an element, you must have a matching closing tag for that element. So XML tags are case sensitive, meaning for example you have let's say you have name tag opened, you have to have a corresponding closing tag. Like you can see here, have the title right here, you have to have the corresponding closing tag. It should be case sensitive. If you've written title in lower cases, the closing tag should also be in lower cases. Should you like use capital T right here, XML will treat these two tags as totally different tags altogether. As you can see right here, let me just show you. You can see right there, they say the error on line 5, opening and ending tag mismatch. It's just because of this case inconsistency. If I just return it to like that, you see the problem is solved. So so that's pretty much Okay, so that's what it means to make it case sensitive. And XML elements must be properly nested. So nesting is very important. Okay, so with nesting, first of all, you make your code readable and you avoid errors. So XML attribute values must be quoted. It's kind of like HTML. So the attribute values must be quoted. We'll see when we run our first XML code. A valid XML document is an XML validated against a DTD, which is a document type definition. Okay, so if it's a valid XML document, means it's well formed, which also confirms the rules of document type definition. So just know that if it's a valid XML document, means it's a well formed XML document, meaning it obeys all rules for writing XML documents, which conforms to the rules of the DTD. So tags are opened first and must close last. Okay, so and this makes sense. So say you open the chapter tag first right here, and then there is an intro tag. The chapter tag that you open first must be closed last. Okay, and this confirms also to nesting. When we start writing, you'll see this, but this is a basic rule in writing XML documents. So in XML attributes, always use quotation marks around the values, like see right here. So we have the intro, the type is chapter. So this type the attribute, so it's written in quotes. Okay, so like I said, the valid XML document has a structure that's valid, that's well known. So if it's valid, means it's well formed. Okay, so to use XML, you need a DTD, document type definition. So a DTD contains the rules for a particular type of XML document. So it's the DTD that defines the language. Okay, so we'll see what the DTD actually is. So that shouldn't give you any problems. So the XML documents use a self-describing and simple syntax. Like I said, it doesn't have predefined tags, so you describe your own tags. So thus, you have a simple syntax. So all elements can have sub-elements, child elements. So you're not constrained into how you nest your elements. So all elements, you can have a sub-element within that element, so giving you the ability to define your data to the atomic detail. Okay, so the term parent, child, and sibling are used to describe relationships between elements. You've done XML, if you've done HTML, you might have seen this. And we'll also see what this is, just basically roughly on top. Okay, so parent elements have children. So if you have children on the same level, they're called siblings, brothers and sisters. It's kind of like how our families are. So you have your father and your mother, for example, they're the parents, and you have these children, they are the children, they are the siblings, they're brothers and sisters to one another. If these children have their own children, that's a sub-child. Okay, so it's just the relationship between the elements in your XML document. Okay, so all elements can have text, content, and attributes, so you're not constrained. Again, I repeat that you can like define your data to this atomic detail. Okay, so the naming rules in XML. So despite it being free and easygoing, it has rules like we've seen in the previous slides. So names can contain letters, numbers, and other characters. Okay, names cannot start with a number or punctuation character. So you have to avoid this. Don't start with a number or punctuation character in naming XML elements. Names cannot start with letters XML or XML because these are reserved keywords. Okay. Names cannot contain spaces. Okay. If you have space in between names, that will actually break your XML code. Any name can be used, no words are reserved apart from the XML or XML. So the best naming practices. So you have to make the name descriptive. This is something that you will find in all programming languages. You have to give it a name that is easy to understand. If somebody like receives your data, they know exactly what your data is all about. Okay. Names with underscore separators are nice, so it's highly advised to use underscores to separate names. Like I said, spaces are not allowed, so instead of spaces, use underscores. So name should be short and simple, like this book title. Okay, that's it's descriptive, it's short, it's simple, it's clean. Not like the title of the book. It's very long, and you, with this practice, you will make your code very messy. Okay, your data hard to interpret. So avoid hyphen characters. Don't use hyphen characters as separators because the hyphen is actually interpreted as a subtraction sign. Actually bring problems on your code. Okay, so if you name something like that first name, separating it using hyphen. So some software may think don't subtract name from first. Avoid dot characters. First dot name. Don't use dot to separate your names. Okay. Some software may think you're trying to access name in the object first. Okay. So just stick to underscores, separate this. So you also have to avoid semicolons as characters. So you have to avoid these as characters because colons are reserved to be used for something called namespaces. Okay, so we'll do this later on. So XML documents have corresponding database. So a good practice is to use the naming rules of your database for the elements in your XML document. So you have these fields in a database. It's very good practice to use the same field names with your XML document elements. Okay, so non-English letters like those are perfectly legal. Like we've done the rules, we've seen what should not be included. It shouldn't start with numbers. So foreign characters, Arabic characters, all can be used. Just make sure that your like software vendor supports them because we have different softwares for interacting. If you stick to the basic XML rules, you should not have any problems. But in case you want to go and do something extra, like using non-English letters, you have to make sure that they're supported by the software vendor that you are using. Okay, so this is our first XML document. Okay, so you can see it generally forms a tree-like structure. So it has perfect nesting, as you can see right here. You can see we're defining the XML version right here. So we have a predefined tag, bookstore. Then we have a book right here. So something to note here is like whatever tag we open, like we open bookstore first, we'll close it last. So whatever tag we open, we have to close it. Any element, any tag is free to have an attribute. Okay. Yes, this increases the descriptiveness of data. So you can see this is the parent. So we have book, which is the child of bookstore. Then we have title, author, year, and price, which are children of the book, which make them siblings. So all these tags are not predefined. Okay, you just write them according to what you want. Okay, so let's see. Okay, so here is this code. Okay, so basically it's like that. So let's say I can add something, like I say um, birth. So what I'm just trying to show you is that you are free to have any kind of tag that you want. I was born today. Okay, so if I go and run this, you can see it's right here. So you can actually just use your own tags. Okay, so it's pretty much it, and you can see the attributes right here. You can define your own attributes for whatever element that you want, just to make your data more descriptive. So the XML document is divided into two parts. So we have the prologue document or the root element. So the prologue includes an XML declaration and a comment. Okay, it can also include other elements such as processing instructions or DTD. So a good example is this right here. You can see this is a XML document. This is the prologue part. It has a DTD right here. Okay, as you can see, it's actually telling to this as the HTML document. Okay, so if you go and try to view this, you can see right here it's been treated as HTML, as sort of HTML, even though it's clearly XML. It's no different from the one that we just seen above. Okay, so the DTD makes the difference here. Okay, so like that. So the DTD tells it okay, so do this in HTML, and that's how it does it. Okay, so well-formed XML documents must have a single document element that may optionally include other content. So any content within an XML document must appear in the document or root element. So any content must appear within the document or the root element. Okay, so this is basically the structure that is. So the XML document right here is divided into two parts. So we have the prologue and the document. So with the prologue, you have processing instructions, you have comments, have DTD schema, and with the XML, the comments are actually displayed as well. As you can see right here, this is an XML comment. Okay, but the rule of thumb is you should start with the XML declaration first, then you can include your comment. If you put this above the XML, you run into problems. It will actually not run. So we have comments, we have DTD schema, as we've seen in this other one right here. So the DTD right here, doc type. So yeah, so that's the prologue part. The document node, this has the elements, as we've seen. So the elements, you can see it has, like, this is the document node. It has these elements right here. We have attributes, we have text, we have the C data. We'll see what C data is. We have entities, and we can also include comments. So these are the major two parts of the XML document. Okay, so with the XML, the first part is the declaration part. So the declaration part um, is actually very important because it tells what version is your XML document, what kind of encoding it use, whether it's standalone or not. Okay. So the element, we've seen what the element is. It's something that you totally define yourself. So let's say right here you have a tag, then you have to have a closing a tag. The way it's written, the way you write it while opening is the way you should write it while closing. Okay. So yeah, so name this refers to tags text example a tag. So just make sure the opening tag is equal to the closing tag. It should be similar in everything, including casing. Okay, just make it descriptive. It is using camel casing right here, but it's much better if you use underscores as for separation. So content is the text between the tags. So if I tell you the content it's just what's between the XML elements. Okay, it's what's between the tags. So parent-child relationships, this will occur between the elements and are given by nesting of the tags. So nesting is really important so that you can have clearly defined parent-child sibling relationships. So attributes can be attached to the opening tag. You don't have an attribute with the closing tag. Attribute values must be enclosed in quotes. We've talked about this. Empty elements can be given by a tag. Comments are any text enclosed in. So this is actually the syntax for commenting, as you have seen right here. So this is how you comment. Just enclose it in these tags right here. Processing instructions, which are available in the prologue part, are defined by the this signs right here. Okay, so you can see right here, these signs right here is what define the processing part. Okay, so if I want to add a comment, for example, I can just say hi, I am a comment. Okay, so if I try to see okay, line 11, yeah, so we have to include this as well. Okay, so this is a comment. Okay, so you can see it's green right there, it's a comment, so you have to include this right here. Okay, so so that's with this slide. So attributes in XML declaration, so we have the XML. So the version part declares what version you're actually using. So this specifies which version of XML or specification document adheres to. There are actually two versions of the XML specification, 1.0 and 1.1. I highly recommend 1.0 for now because it's basically supported in like everything that does XML. But 1.1 being a newer version is not widely supported as with 1.0. That depends on when we'll be watching this tutorial. Maybe in the far future it will be supported in every software device, software vendor, but for now it's pretty much a recommendation to stick with 1.0. Okay, so encoding declaration identifies which encoding is used to represent the characters in the document. For example, you have the UTF-8 encoding, you have the UTF-16 encoding, you have the ISO Unicode encoding. So this basically is up to you with whatever purpose you have for your data. Is you get to decide what encoding to use depending on what data you're transferring. Okay, so this is majorly up to you, but you have to write it. Okay, standalone. So this standalone attribute actually declares or indicates whether a document relies on information from an external source, such as an extended document type definition for its content. So it's either yes or no. If it's yes, it means if standalone equals to yes, means the document is non-dependent on other sources. If it's no, it means it depends on an external DTD. So structure of an XML page. So by now I'm sure you already have a grasp or good understanding of what the structure of an XML page is, but just to jog your memory, so this is actually what we're referring to with an XML page structure. So we have the prog part, we've defined the processing information. Then we have the document node, we have the root, which is the parents, we have the element with the children, we have the sub element with the sub children. So yeah, so it's something that's actually pretty easy to get with. Okay, so right here we have an XML page example. Okay, so what we'll do now is I'll just define something just to get you practicing. So let's just so I have the XML. Let's close it. Okay. So we define the version first equals to. So you have to define the attributes within quotes. So encoding. Let's use ISO encoding. ISO encoding. The standalone. Let's say yes. So standalone equals to yes. So I'm just going to define pretty much just two tags. So let's have let's say the student. Then I'm gonna close the student. Okay, so I'm gonna close the student. The name, just say name of the student is Ali. I'm just gonna close him. So this is an example of a very valid XML document. You can see right here, it's very simple. Okay, so that's pretty much how you do it. Okay, so let me just return to what I had before. Okay, now so that's pretty much how you write XML code. So the version is a must to have. The encoding and standalone, some things that you can just define for higher flexibility, but they're not a requirement really. Okay, so by now you already know like nesting. You know that you open an element, you have to close it. You open it first, you have to close it last. You know that elements can have children. Children can have children within the same level, making them siblings. So things to note. Okay, so the C data section. Okay, so this is pretty much important, and you have to get a grasp of its syntax. So the C data stands for for the character data. So it means that the data between the strings include data that could be interpreted as XML markup but should not be. Okay, so right there you can see right there y is 9 less sign 10. Okay, so you have with statement like this is a must to include it in a C data. Okay, because the less sign right here will be interpreted as an opening tag. So XML will see this as an opening tag, and we'll want to see an element being defined in here. So it will check if you're trying to close this title tag and it won't see anything, so it will actually result into errors. But if it's in a C data, it will not be interpreted as such. Okay, so let's try to see this. You can see right here, I just use this tester right here. It said my C data y is 9 less than 10. Okay, but if I were to get rid of this C data right here, okay, just let's get rid of it. Okay, so it says on line 7 at column 37, start tag invalid element name y is 9. This is where the tag appears, so it's trying to see it's a start tag, but it doesn't see it being closed, it doesn't see anything, so it actually results into errors. Okay, and this is why you should have the C data. So how do you actually write the C data? So the C data is written like this. So you have this, then you put that, then you open C data. Later after that, then you close it, and within in between right here you write this, then it works. Okay, so we have two square brackets. I have this comment like sign. So this is pretty much the syntax for writing the C data. So it's very important if you write, say, if you're writing something that might be interpreted as say an XML element, something that could be interpreted as an XML code, but you don't want it to be interpreted as such. Okay, so use the C data. So you can use C data section in XML documents for embedding code such as JavaScript. Yeah, you want to embed it as the way it is original. You don't want to be interpreted, so use C data to assure this. Use C data for safety. So if you use C data, data will be as how you want it to be. The way you've written it, it's the way it will be displayed. Okay, so the key difference between C data and comments are C data is still part of the document while comment is not. So a comment is not part of the document. Okay, and in fact, if you look at this other example right here, this comment right here, this is a comment. Okay, this is a comment. If I open this right here, let me open this second document, you will see using a comment, using C data section. With using a comment, nothing is displayed because the comment is not part of the document. While using C data section, you will see that it's being displayed. Okay, you can see using a comment, we have a comment right here. It's not being displayed entirely because it's not part of the document. It's a comment. It's not being interpreted. It's not being displayed. It's not being rendered. Okay, but C data is actually part of the document. Okay, this is actually the major difference between the two. Okay, so so displaying on the web. So an XML document is rendered as a raw XML text by most web browsers. You can see the web browser that I'm using. I'm using Chromium, and you can see the way it's rendered. It's actually raw XML text. Okay, no fancy styles, no nothing. It's just raw text like that. You can see right here. You can see it's being rendered as raw text up like this. Okay, it's responsive, but it's raw. Everything is being seen. XML file does not appear to have any styles associated with it. Okay, so that's majorly how it's being displayed. Okay, some displayed with handles, example plus negative signs at the margin, which allow part of the structure to be expanded or collapsed with mouse clicks. Mine does it using arrows, like you can see right here. You can expand it, and yeah. So you need style sheets, CSS or XSLT to render display of your choice. Like I said, we're just doing transfer and display and transfer and transfer of data. Okay, so the way it actually appears to the user is up to you to use another language to support that. So XSLT, which is Extensible Style Sheet Language, is styling language for XML. Just as CSS is a common styling sheet for HTML, so XSLT, Extensible Style Sheet Language, is a common styling language for the XML. Okay, so displaying on the web. So if you want to display on the web, you are actually displaying to your users. You don't want to have something like this to a user, because a non-technical user will actually misinterpret this like something, maybe it's an error, or it's not something pleasing to a non-technical user. Even a technical user, you want something that's pleasant to look at, something that they can work with ease. Okay, so like for example, this you can just display it in a tabular form, be much more better compared to if you display it in this manner. Okay, so in order to style the rendering in a browser with CSS or XSLT, the XML document must include a reference to the style sheet. Okay, so just like it is declare it like in the processing part, XML style sheet type. If you're using CSS, it's text/CSS href to the style sheet. If you're using XSLT, just say text/XML, then you link your XSLT file. Okay, so the XML document structure. So an XML document uses two auxiliary files. We have the schema file, which is the DTD XML schema, or one of the several other style files, and you have the CSS. Okay, so with the CSS have XSLT, Extensible Style Sheet Language, which is created for this purpose. Okay, so an XML document is a tree of elements with a single root. So a document has a single root. Okay, like we've seen when we were looking at the structure. So we define our own tags. If you want to use a tag, you have to define its meaning. Okay, this definition is stored in the DTD. You can define your own DTD or use an existing one. An alternative for DTD is schema. So a schema file. The HTML document, the XML document type declaration DTD is a way to describe XML language precisely. Okay, so document type declaration. So it's a way to describe the language precisely. Okay, so it checks for the vocabulary and validity of the structure of the XML documents against grammatical rules of XML appropriate language. So an XML DTD can be either specified inside the document, or it can be kept in a separate document, then linked separately. Okay, so it's supposed to be linked. So the basic syntax of a DTD is like seen there. So this is the basic syntax. So you have the DTD declaration right here, then you can have your declarations inside. So you can either have this within the XML document or in another file, then you can link it. So the DTD starts with document doc type delimiter, as we've seen right here. So the doc type, so this is an HTML. Okay, so it starts with this doc type delimiter. So an element tells the parser pass the document from the specified root element. So DTD identifier. This just means identifier for the document type definition, which may be the path to a file on the system or URL to a file on the internet. Okay, so it depends where the file is, you just link to it. If it's from the internet, you put its URL. If it's local, you just put its path. So if the DTD is pointing to an external path, it's called external subset. Okay, if if the square brackets includes an optional list of entity declaration called internal subset. Okay, so an internal DTD is referred to as such if elements are declared within the XML files. Means the DTD is declared within the single XML file. That's internal DTD. If it's from another source, then that's external. So to refer it as internal DTD, standalone attribute in XML declaration must be set to yes, meaning it does not depend on any other documents. Okay, if you're using internal DTD. Okay, but if using external DTD, standalone must be set to no. Okay, so for example, this is an example for an internal DTD. So you have your XML processing information right there, then you are DTD. So the doc type address, you have the element. So that element address, it has name, company, and phone. So the other element is name, it has PC data, you have company name, like that. Okay, so this is example of internal DTD. So like I said, from the syntax, you have to have square brackets, then you have the declarations. Why do you use DTD? You use it so that you can define the elements that we're using inside. Okay, so those are elements, so they're clearly defined and ready to use. Is standalone? Yes, because everything is written inside. Okay, so in cases where like I've already defined elements that I'm using, doc type address, for example, element address has name, company, and phone. So there's name, there's company, there's phone. You can see right here, you just did address tag, then you have the name, then you have the company right there, then you have the phone. Okay, so I've already predefined all of them in my DTD declarations. Okay, so example of the internal DTD. So the doc type declaration has an exclamation mark at the start. I've seen this. So the doc type informs the parser that DTD is associated with this XML document. The DTD body, the doc type declaration is followed by a body of the DTD where you declare elements, attributes, entities, and notations. Okay, so that's pretty much it. So the elements, you can see, all start with an exclamation mark, then the actual element, then is definition. Okay, so this is the example that we had before. So several elements are declared here that make up the vocabulary for the name document. Okay, so elements name PC data defines element name to be of type PC data. So PC data just means parsable text data. Okay, so it's parsable text data. So it's pretty much how to define internal DTD. So following some of the important points, this describes the elements can appear in an XML document, the order in which they can appear, optional and mandatory elements attributes, and whether they are optional or mandatory, whether attributes can have default values. So when you're doing DTD, these are things, these are things that you can do with it. Okay, so elements that can appear in an XML document, you define them there, you declare them there. The other elements that can appear, you can declare it there. Whether it's option mandatory element, you can declare it there. If the elementary attributes and whether they are optional mandatory, you declare it there as well. Okay, whether they can have default values in case they have not been given no value, you can declare it in the DTD. So the XML document structure. So XML has 5 predefined entities. So we have the and, the ampersand, less than, greater than, and apos, which is for apostrophe, have the quotation mark. So these are predefined. And with this, so for example, company AT&T. Okay, so with this you have to make sure you use the C data. It's because they're predefined. It means if you do not use them with C data, they will be misinterpreted, may result into errors. Though it depends on what you want to use them for. Okay, so in case you want them to be displayed as they are, you have to use the C data as we described above. Okay, so the user can only define entities in a DTD. If several predefined entities must appear in each other, use character data section. Okay, means the whatever is written inside will not be interpreted as XML code. Okay, so instead of using it directly, like instead of using start here directly, you just put it in a C data and to be rendered without any problems. You're doing comparison, you're going to use less greater signs, you're going to use ampersand sign. You have to put it in a C data, then and only then will they be displayed exactly the way they appear. So how can XML be used? So XML separates data from HTML. So with XML, data can be stored in a separate XML file, which you've seen. You can just create an XML file. This way you can concentrate on using HTML for layout and display. So you don't have to worry on how you don't have to worry on the data, you just have to worry on the display. Then you can just link the XML and the data will be defined as to how you have set the layout in your HTML. So if you need to display dynamic data in your HTML document, it will take a lot of work to edit the HTML each time we data change. But with an external XML file, so actually you just edit your data and it will be like linked successfully to your HTML. So it separates the data from HTML. It gives you the opportunity to focus only on the layout when doing XML, okay, without having to worry on the data part. So XML still simplifies data sharing. Okay, it simplifies data sharing. So computer systems and database contain data in incompatible formats. Okay, so you have something uses MongoDB, for example, then you have somebody else uses Postgres, somebody else uses MySQL. Okay, you have all those different types of databases, but with XML you can share data stored in a plain text format that all systems and databases can easily understand. So this provides a software and hardware independent way of storing and sharing data. So this makes it much easier to create data that different applications can share. XML simplifies platform changes. Upgrade to new systems, hardware or software platforms is always very time consuming because you have to not only upgrade but you have to ensure compatibility, you have to work on the software, the hardware, whether they are dependent, many issues. So with XML upgrading to new systems, you don't have to worry on the data part because it's just text format. It won't have any problem, it will be easy be interpreted. Okay, so large amounts of data must be converted, and incompatible data is often lost. So since XML data is stored in text format, it makes it easier to expand or upgrade to new operating systems, new applications, or new browsers without losing any data at all. So XML simplifies data transport. Okay, so one of the most time-consuming challenges for developers is to exchange data between incompatible systems over the internet. So with XML, data can be easily exchanged between incompatible systems. Okay, uh, so so exchanging data using XML greatly reduces complexity, since the data can be read by different incompatible applications. Okay, so XML makes your data more available. Because since XML is independent of hardware, software, and application, XML can make your data more available and useful. So different applications can access your data not only in HTML page, but also from XML data sources. Okay, it is compatible, it is readily available. So with XML, your data can be available to all kinds of reading machines, handheld computers, voice machines, news feeds, is textual. And there's no machine that doesn't understand text to data. It's actually a very basic form of data. Okay, so XML is also used to create new internet languages. For example, since it's a meta language, it can be used to define other languages. So HTML is the latest version of HTML, WSDL for describing available web services, WAP and WML as markup languages for handheld devices. RSS is very common language for news feeds. RDF, OWL for describing resources and ontology. SMIL for describing multimedia for the web. Many of these languages actually languages you've never heard of before, but all being derived from XML. And that does it for this lecture. Okay, so stay tuned for coming lectures. Hope you enjoyed. If there's any questions, you drop them in the comment section below. Something you didn't grasp, something you didn't get the hang of, drop in the comment section below. Like, share this video, that more can get enlightened on this topic. So until next time, stay safe.